Okay, let's get started. Hello everyone, this is IERG4998, final year project 1, and you can call me Steven. My topic is the design and implementation of the consolidated system with AutoML tools and algorithms. Currently, the machine learning skills are widely used in many fields in our daily life. In 2017, Google developed AutoML. It has some modules that can automate the tedious parameter tuning process for data scientists. However, we found these tools do not guarantee that it always gives the optimal solution. So in our project, we will establish a theoretical foundation of the classification algorithms used in AutoML package. Then we can compare the performance of different modules in AutoML from the rank of Titanic datasets on Kaggle. Finally, we will manually tune some hyperparameters in these algorithms and compare their performance with those in the automated module. And the dataset we are using is the Kaggle Titanic. This dataset is frequently used in Kaggle data science computation. The problem is to predict which kind of passengers are more likely to be survived in the Titanic accident. For example, from our common sense, women, children, and passengers in upper class are more likely to survive in accident. And this dataset has totally 21 features. The correlation of each features is shown in this heat map. From each pair of features x and y, if the correlation of them is greater than 0, we say that they are positively correlated. Otherwise, we say they are negative correlated. And the algorithms we are using is the classification algorithm. The first is the logistic regression. And for n different features x b to b x1 to xn, we first define the hypothesis function of the logistic regression to be 1 over 1 plus e2 minus theta tx. So the probability of y parameterized by x and theta can be expressed as these following formulas. You can see this makes sense because as y goes to 1, the second term will be disappeared, and otherwise the first term will be cancelled, and the second term will be the major part. And in order to get the appropriate parameter matrix theta, we need to make a maximum likelihood estimation on the L of theta. And then we use the gradient descent method to find the optimal theta until it's convergent for all j. And another algorithm is the artificial neural network. We use 3 layers network structure. The input layer is the features, and in the hidden layer, we set the active function to be the rectified linear unit ReLU function, and then we can get the output of each node. Similarly, we applied the sigmoid function in the second layer to get the outcome. Hence, we can use the gradient descent again to minimize our cost function j of theta. then we can use the then we can see the performance of different modules in AutoML on Kaggle. It works quite well when we look at the public score. So we can compare their accuracy. For Titanic classification problem, the rank of the toolbox in the AutoSkilearn is better than Keras, and Keras is better than Teapot, and Teapot is better than H2O. This is the rank of different modules. After that, we will manually tune some hyperparameters in the above algorithms to see the optimal value we can get. The first figure is the relationship between the number of iterations in the gradient descent of the logistic regression and the accuracy. We can see as the iteration number increases, the accuracy also increases, then it goes stable. And the rest three figures shows the hyperparameters in the artificial neural network. From these figures, we can get that the optimal accuracy of both algorithms is higher than 80%, but none of the scores in the automated module is greater than 0.8. So it means that the automated module is not as good as the manually tuned parameters. So up to now, I have built up the theoretical foundation of two important classification algorithms applied in the AutoML systems, which is the logistic regression and artificial neural network. And moreover, we compared the performance of automated pipelines on the certain dataset in Kaggle, including Teapot, AutoSkilearn, and so on. From our experiment, we found that the modules are applicable in the classification problem. However, from manually parameter tuning, we found they cannot provide the optimal solution. So our next step is to apply these toolbox in some more complex dataset, such as image recognition or horse price prediction, and to establish an original pipeline that select the best performing model with the auto-tuned hyperparameters. That's all for my final year project. Thank you very much for watching this video. That's all. Thanks.